Hi, ma'am, we are live, ma'am, please.
Oh, yeah, sure. Good evening, everyone. So in this session, today my plan is, I'll try to discuss that how do we input matrices in Mathematica, and then we will also try to see its various properties, like how to find the eigenvalues, how to find the eigenvectors of a given matrix, and then we'll try to also check the different kinds of matrices. For example, if any given matrix is whether it is symmetric or anti-symmetric, and then whether how to check whether a given matrix is orthogonal, and then finally we'll try to diagonalize a given matrix. Okay, so this is today's plan, and then few more I would like to tell you few more things in Mathematica which would be of great use, okay, for your calculations and for your problems which you are doing for the classical mechanics course and also for other courses, whatever you all are doing. Okay, so let me, so today also I have recorded a short video for you all so that it goes smoothly. And then later on, I'll discuss few more important properties, okay? So let me share my screen. Hello, everyone. So I would like to emphasize once again that you all can make a free account on wolframcloud.com. There's no need to buy this software, okay? And then you can just open a new notebook and you can start doing the computations, okay? And two, three important points which you all should remember every time is that for all the built-in functions, you all should use capital letters, and the arguments will always be included in square brackets. Okay, so in between, wherever required, I'll be emphasizing those. So it would be really nice if you all can also open a new notebook with me and try to do all these computations. So it will be kind of a hands-on session. If you face any difficulty, you can type your problems in the chat. Okay, I'll keep an eye on the chat. And if there are any questions, I would reply them. Okay. So today's plan is that I would like to review some of the important types of matrices, how to input them in Mathematica, and then we'll discuss different types of matrices, how we can check their properties, and then also that how we can construct an orthogonal matrix and how we can diagonalize the matrix. So this is the plan of today's lecture. So let us try to see. First of all, let us give a title. Today's lecture. Okay, let us come out of this. Already I have mentioned in my last lecture that you all can make a free account on wolframcloud.com and then you can pursue your calculations. So whatever problems you're doing in the classical mechanics course or in any other course, you can cross-check most of them and you can visualize them in this software. Okay, so let us try to see how to input a matrix in Mathematica. So let us input a 3x3 matrix. Okay, so the basic syntax to include a matrix in Mathematica is to include the different rows of a matrix in curly brackets. Okay, so this is the main curly bracket, and inside that I would like to have 3x3 matrix. For that I will have 3 rows. Okay, like this. So I'll just increase the font so you can see better. Now here, I will input the different elements of the rows. Now, Shift Enter. So this is how I can input a matrix in Mathematica. Now I can do any operation on this. For example, also, you can also see this in matrix form. But the only problem is that if you write this in a matrix form, then you won't be able to do any operation. For example, if I would like to see this in a matrix form, so here you can see. Just a sec. Yeah. So this is how you can see this matrix in the matrix form. But then the problem is that if I do any operation on this matrix, then it won't work. For example, if I would like to find the transpose of this matrix, okay, then it will not work. But if I remove this, again shift enter, okay. And then if I run this command, it will give the answer, okay. So you can always check, but in order to do the operation, you have to write the matrix in this form. Now I can find the transpose of this matrix. Let us check how to find the determinant of this matrix. The command for that is det. Okay, so it will give you the determinant of this matrix. For example, if you're doing some calculation with the hand and you would like to cross check, then it's very easy to see here. Now, let us try to find the eigenvalues of this matrix. Okay, if you just type eigen, it will give you eigenvalues, eigenvectors, eigensystem, eigenvector centrality. So as of now, we'll be trying to find eigenvalues and eigenvectors. That's what we require to do many problems in classical mechanics, right? So here, okay, so these are the eigenvalues: 1 plus root 2, comma 2, comma 1 minus root 2. Okay, so these are the eigenvalues. Let us try to find eigenvectors. If you do it by hand, it will take some time, but here you can check in few seconds. Eigenvectors of E. So this is how you can easily get the eigenvectors. And this, the matrix, which includes eigenvectors of this matrix, that will also help us to find to diagnose this matrix. Okay, that I'll very soon will try to see that. Now, another very important thing which we often require to find is the inverse of this matrix. So let us try to find the inverse. So let me give a name INA. Let us take this. And I would like to find the inverse. Now there is a very simple way, and which is very obvious, to check whether this inverse is correct or not. I can take the dot product of this inverse of a matrix with the matrix itself, and then it should give me identity. So let me check the dot product of A and inverse of A. So A dot INA. If we give a name like this, then there is no need to type the full function. Okay, and which clearly shows that the inverse is correct, and I get an identity matrix. Okay, so these are the few important things which we often require to do our computations in classical mechanics course, right? To find the transpose of the matrix, determinant, eigenvalues, eigenvectors, inverse, and you can check whether that inverse is correct or not. Another important thing, all these are built-in functions which start with capital letters, which I have already mentioned in my previous lecture, and then the argument will be enclosed in a square bracket. Only the difference is here that in order to input a matrix, you need to input the matrix in a curly brackets. Okay, so these were the few things which I would like to tell you all. Now moving further, let us try to check the different types of matrices. So the first most important type of matrix which we came across while doing the course was the symmetric and anti-symmetric matrix. So let us try to check whether a given matrix is symmetric or anti-symmetric. I can write here, a given matrix will be a symmetric matrix only if it is equal to its transpose. Okay, so this was the definition which we all have learned. And also we can check its properties, like how many independent entries are there, for example, in a given symmetric matrix. This is a very important question we generally ask. Now we come out and I input a symmetric matrix. Let us say M is equal to, for example, some matrix is given to me. And I don't know whether this is a symmetric matrix or not. And I would like to check it. 1, 7, 3, 7, 4, 5. Okay, 3, 5, 0. Let's increase the font of this. Okay, now let us check whether this 3 cross 3 matrix is symmetric or not. So the simple way to check this is as just to find the transpose. Transpose of M. And this should be equal to the matrix itself. So I have to input the matrix. And one more thing, you see that what mistake I have done. I have written the matrix in the same cell of the title. So it will not work. We have to come out of the cell of the title and then we have to write in a different cell, which is a code cell. Okay. So for example, let me copy this, Command C. And then I have to come out of this and then paste. So it's typing in the same cell actually. You can see here that it's the same cell, so it will not work. The same cell actually. Yeah, M is equal to Command V. Yeah. Okay, so this is a different cell. Now let us try to take the transpose of this. Okay, and we see that the transpose of the matrix is the matrix itself. This shows that this given matrix is symmetric. Another important thing we can check here is, for example, if I would like to write in the matrix form, and I would like to carefully see how many independent entries are there in the given symmetric matrix. Okay, so now there are total, it's a 3 cross 3 matrix, there are total 9 elements. And by carefully looking at the matrix, we can see that not all the 9 elements are independent. 7, 3, 5 on one side of the diagonal is same as 7, 3, 5 on the other side of the diagonal. So 3 elements are same. So the number of elements which are left independent are 9 minus 3, 6. Also, one can check this with the help of the formula directly. N into n plus 1 by 2. N is 3. 3 into 4 by 2 is 6. Okay. And if I would like to put any additional constraint on this, for example, let us try to find the number of independent elements for a real symmetric 3 cross 3 and traceless matrix. then I will be having one more constraint, that the addition of the elements of the diagonal is 0. That is, the matrix is traceless. Total number of independent elements are 6. Then what will happen? With one more constraint, I'll get total number of independent elements as 5. Okay, so these are the few common things which we should know about these matrices. Now let us try to see how do we check any anti-symmetric matrix. Again, let me put a label. Okay. And the definition of anti-symmetric is when the matrix is equal to its minus of its transpose. So M, let me take N, is equal to minus of transpose of N. Okay, this is my basic definition. Let us try to take. Now, one can easily think of any matrix which be antisymmetric. All the elements should be negative of, the transpose should be negative of the matrix itself. It means in order to construct an antisymmetric matrix, obviously the diagonal elements will be 0. One side of the diagonal will be positive, other side of the diagonal will be the elements which are negative of those elements. Okay, so let us try to take one matrix which is antisymmetric and try to check. Okay, so 0, 1, 3, first row, -1, 0, 2, let us take this, and then let us take -3, -2, 0. I try to run this, shift enter. Symbol N is protected. What do we mean by this? That already Mathematica has already used capital N as a protected symbol. It means that there is something already used as a built-in function with capital N. So it will be better if we don't use this. Let us take this as P. Okay, here also I can change P. And then again I run. So now that error has gone. So one should not use. If you get such kind of error messages, so please be careful, because otherwise it can sometimes take some default values which is already stored in the software. Now let me try to take transpose of P. Okay, and if I take minus of transpose of P, I should get the matrix itself. Yeah, this shows that this is an antisymmetric matrix. And in order to see number of independent elements in antisymmetric matrix, and there is no meaning of traceless, all the antisymmetric matrices are traceless. So one can check the matrix form, because sometimes it is difficult to see the matrix like this. So it is better to always write in the matrix form. Okay, and one can see that total number of elements are 9 and 3 are same as 1, 3, 2 are dependent on this, negative of these two. So how many dependent elements do we have? 3. And you can also check with the help of formula n into n minus 1 by 2. So 3 minus 3 into 2 by 2 is 3. This is how one can easily check how many independent entries are there in the antisymmetric matrix. Okay. Now moving further, another very important matrices which we come across in the class and mechanics courses, the orthogonal matrix. How to construct an orthogonal matrix. Okay, let us try to see that. Again, I would like to give a title. In order to construct an orthogonal matrix, let us choose a set of orthonormal vectors. Now, what do we mean by orthonormal vectors? Let us try to see. Let me take a set of 3 vectors and I will show you that how these 3 vectors are orthonormal vectors. Okay, so let me input 3 vectors, V1. Again, a vector, I'm taking a vector with 3 elements. Okay, 1 by square root of 2. How do I write square root in Mathematica? SQRT. Okay, and everything, the elements will be written in the form of a list, whether I write a vector or whether I write a matrix. In matrix also, all the rows will be separated by commas and will be entered as a list. Comma 0, comma. Again, let me take -1 by, because I have already checked that these 3 vectors are orthonormal. So I'm taking the same, but I will show you. It's QRT. So this is my first vector. In the same cell, I would like to write another vector so that I can run together. One by 2, comma, minus square root of 2 by 2, comma, 1 by 2. This is the second vector. Third vector, just enter so that we can write in the same cell. Enclosed in curly bracket, 1 by 2, square root of 2 by 2, comma, 1 by 2. Now, let me run this. First, let me increase the font so that it is clearly visible. Okay, so you can see I have chosen 3 vectors. Yeah, you can see this in a vector form. 1 by root 2, 0, minus 1 by root 2, 1 by 2, minus 1 by 2, 1 by root 2, 1 by 2, 1 by 2, 1 by root 2, 1 by 2. Now, our first step is I'm claiming that these 3 vectors are orthonormal. How to check that? In order to check whether these 3 vectors are orthogonal and they are also normal, I will check their dot products and also I will check their magnitude. So to check that, check whether these vectors are orthogonal. Okay. Yeah. Okay. How do I check that? I calculate V1 dot V2 in the same cell. Enter V1 dot V3. Again, enter V1. So, for example, if you're doing some computation in Mathematica, okay, and then it changes color, you have written some certain syntax, and the color is different, then that will give you an idea that there is some mistake in the syntax of the whatever you have written, and also if you are writing the text, the color will change. Okay, so that will give you an idea whether you are doing you have written whatever you have written is correct or wrong. Okay, and then you can check and see the error messages. Sorry, V2 dot V3. So I will check the dot product of all these 3 vectors with all the possible combinations. Okay, and this should come out to be 0 if they're perpendicular to each other, right? So this is the first step to check whether these vectors are orthogonal. Now, to check whether these are normal, check whether these vectors are normal also. I will check v1 dot v1, v2 dot v2. So please pay attention here that I'm writing all these three vectors in the same cell. Because writing something in the same cell, if you run that, it'll calculate together. You can do it differently also, but it is just a bit convenient. v3 dot v3. Now, again, I have written this 3 in the same cell. And let me run this. And this has come out to be 1, what I should expect. These two things shows that this set of vectors which I have chosen are orthonormal vectors. Okay. Now, constructing a matrix with these 3 orthonormal vectors, what I will get? I expect to get an orthogonal matrix. Now, constructing a matrix with these orthonormal vectors, I expect to get an orthogonal matrix. Let us check that. So now, let me take as O is equal to, okay, so I would like to have 3. You can copy from the top. So let me, first vector, copy. This is the first element of the matrix. Okay. First row of the matrix, sorry. Copy. Then second row. Okay. And third row. Yeah. And let us run this. So what do I expect? If I construct a matrix with 3 orthogonal vectors, I expect that matrix to be an orthogonal matrix. So this is again a 3 cross 3 matrix. Okay. So I have taken those 3 orthonormal vectors, and using those orthonormal vectors, I have constructed a 3 cross 3 matrix. Okay. Now let us check whether this matrix is orthogonal or not. Check that. How do we check that? Whether a given matrix is orthogonal or not. So I will take the transpose of an orthogonal matrix, and then O dot O transpose should be equal to 1. Okay. Yeah. Now let me take that OT. I just denote is equal to transpose of O. Okay, and then O dot OT. This should be equal to 1. So that, which will confirm that this is an orthogonal matrix. Yeah. And we get an identity matrix. So this is how one can check all the matrices in Mathematica very easily, whether the given matrix is orthogonal or not. Okay, first you check whether that set of vectors is orthonormal, and then we can check that the matrix is orthogonal. Now, another very important thing, which was also a part of assignment 0 of classical mechanics, that how to diagonalize a matrix. Okay, so that is also we can easily check in Mathematica. First, we need to find the diagonalizing matrix, and then we need to check whether with the help of that diagonalizing matrix, we can diagonalize the matrix. You should always first do the computation with hand for the first time. Don't do directly in any tool or software, because that will not give you the insight of all the steps. But this software will help you to visualize a lot of things about the different kinds of functions and also will help you to cross-check your calculations easily, because sometimes you need to do the repetitive job. then there is no need to do all the computations by hand again and again. So let us try to see how to diagonalize a matrix. Because doing by hand, it takes a quite amount of time. But here, one can do easily. Diagonalizing ratio of a given matrix. Okay. Now, let us take one matrix X and input. Again, let us take 3 cross 3 matrix. Here, I would like to emphasize one thing, that not all the matrices are diagonalizable. Okay, so here I've chosen a matrix which can be diagonalized. So please don't think that you can take any matrix and diagonalize it. Okay, so for example, only real symmetric matrices can be diagonalized, and similarly, there are other properties. Okay, 3, comma, -2, comma, 4, -2, comma, 6, comma, 2. 4, comma, 2, comma, 3. Okay, let us try to input this matrix in Mathematica. And now, in order to find the diagonalizing matrix, we know that the matrix which is formed with the eigenvectors of this matrix serves the purpose of the diagonalizing matrix. So I can find that. Let me try to see. For example, I take U is equal to eigenvectors of X. Okay, 1, 0, 1, -1, 2, 0. So this is a matrix which is formed by the eigenvectors, and this is the diagonalizing matrix. Now, let us check whether with the help of this diagonalizing matrix, I am able to diagonalize the matrix X. So it means, okay, so once again, I'll emphasize here that the diagonalizing matrix for this X is constructed with the help of the eigenvectors. Okay, so this is U is my diagonalizing matrix. Now I will check how, by writing U X U inverse, whether I get a diagonal matrix or not. The final result should be diagonal. I should get only the entries on the diagonal. So let me take, for that I require inverse of U is equal to, you all might have learned in your mathematics course. And it's very easy to check also. So this is another important point, that in order to diagonalize a matrix, when I'm writing the diagonalizing matrix, its inverse should exist. Otherwise, then it will not be able to diagonalize the matrix. Okay, this is obvious that its inverse should exist. Okay, so this is the inverse of U. Now, if I write U X inverse of U, what do I get? U dot X dot inverse of U. Okay. What is this? You can, on the left hand side, you can take U inverse, here also U inverse. Okay. So U inverse U will give you identity, and here also inverse U will give you identity. And this should give you the diagonal matrix. Yeah. So this is how, so finally, this quantity U X inverse of U makes the matrix diagonal. Okay, and this one can see that we have only the diagonal entries in the 3 cross 3 matrix. And this one can check by multiplying on the left with UU inverse and also on the right with UU inverse, because identity can always multiply with the identity matrix anyway, and you can check the equation. Okay, you get ux u inverse. Now this is how one can check or one can diagonalize the matrix. This was, I think, given as one of the questions in the assignment 0. So I hope I have covered all the questions in the assignment 0. Now my further plan is to do some problems of classical mechanics and Mathematica. For example, we can discuss the case of the triatomic molecule, how to find the different kinds of the normal modes. Okay. And also I plan to do some problems of oscillations. I would like to visualize you and to show you how you can see the different kinds of oscillation, damped, force in Mathematica. Okay, so that would be the plan for the next session. Okay. If you have any problems, you can always write in the chat and ask me. Okay, thank you. Yeah. So now I will show you. We have already diagonalized the matrix, but one more point I would like to make it here, that the diagonal matrix which you got finally, you can also, so basically that diagonal matrix consists of the eigenvalues of the matrix X. Okay, so what you can check in the final equation, u dot x dot u inverse, this is equal to D. That is the diagonal matrix which you got. If left side I multiply by u inverse on both the left hand side, right hand side. Okay, so it will give me, and on the right hand side, if I take u, so on the right hand side I will get u inverse du. Okay, and if I construct a matrix using the eigenvalues and try to check that, you will get the matrix X back. Okay, that is another check which you all can do, whether you have diagonalized the matrix correctly or not. Now I would like to show you one or two more important functions which you can use, the built-in functions which you can use in Mathematica, and those will be very helpful to do various computations. For example, if I generate a list of values, so let me share my screen once again. Yeah. So for example, I'm generating a list of values. Just a sec. So when we use Mathematica, actually with a live meeting, it becomes a little slow. Okay. So now let me input a matrix. Let me take B is equal to, I will increase the font. Okay. I'm generating table. This already I have discussed in my last lecture. Table x square, where x varies from 1 to 10. Okay, so now here I have generated 10 values. Sorry, here you need to specify what variable you are varying. Okay, by reading the error message, you can just correct your code. Now 10 values, they have been generated. I would like to choose the third value or second value, anything. So the syntax for that would be B, square brackets for the argument, and I would like to choose the second element of the list. So the syntax would be again square bracket inside 2. It means second element of the list. This is very useful. For example, we have to do some computation or something only on the few elements of the list. Then you can choose that. So second element of this list is 4. So this is very, very useful. Another important thing, another important function, which one can use. For example, I have simplified some expression and I would like to substitute anything in that expression. So let us take, in order to simplify any expression, we use full simplifier. This is also very useful. Let me take any complicated expression, algebraic expression I'm taking here. X to the power 5 plus 2x 4 plus anything you can take. It's just an example. Okay. And you would like to simplify this expression. Yeah. So this will simplify your expression. Now, in this expression, I would like to substitute the value of x as 2. Okay, this is also very, very common. We require to do in many computations. Then what we can do, one method is directly in this expression, one can do, that is slash dot x. You can make an arrow with the help of a hyphen and the greater sign, 2. Okay, so directly, so what is the meaning of this? Is replace that in this expression, after simplification, one can replace x with 2. Okay, if I run this, you will get some finite value. If you do not wish to substitute at the same time, for example, I would like to substitute later on, then you can give a name to this function. Let us take f is equal to and I remove this. Once again, I run this. Again, I got that expression. Now, in f, I would like to substitute x goes to. So I'm doing the same thing which I did earlier. Here, earlier I have substituted directly, but now I would like to substitute separately. Because I may check, I would like to substitute x as 2, or I would like to also check x3, then this is useful. So I got the same value which I got earlier. Now I would like to substitute something else. Then you can simply x3. Okay, you can do this. So this is also very, very important functions which one can use or do in the while doing the competitions, one can use. Okay, so let me stop here. Most of the properties, important things which we have used in few weeks in the course of class mechanics, I have covered. Now we need to, I'll try to do few examples. For example, to help you visualization of the oscillations in Mathematica, how one can see, or very beautifully one can plot the curves of the damped oscillations, forced oscillations. I'll try to do that. And also, if possible, I'll try to do triatomic molecule. Okay. So thank you for now. And if you have any questions later on also, you can post in the discussion forum. Okay, I'll reply to that. Okay, thank you so much.